All right, good afternoon, everybody. We're going to continue with our note taker for the last couple of examples, kind of continuing the same idea of what we've been doing in class, identifying the key characteristics of an ellipse to then write the equation. So it says write the equation of the ellipse with the given conditions. This is the vertices, -2, 10, -2, -2. We're seeing that the y values are changing. So this seems like the major axis. This is a vertical stretch since the y values are the values that are increasing or that have changed, where the center would be the midpoint, right, of these two distances or these 2 points on the vertices, right? Well, the midpoint of -2 and -2 is -2, or the average. And what is the average y value? We're going from 10 to -2. What is the average distance there? Where would be that value? It would be 4. That would be our center. Then we know that the major axis is vertical. Because the y values are the ones that have increased. And we know that if the center is, -2, 4, and the physical distances of the vertices would make the length of the major axis. So the length of major axis is the distance from 10 to -2. That's 12. And remember, the reason we ask for the length of the major axis is to find the variable a, which means a equals 6. And we're going to have to use a squared at some point. So let's just find a squared to 36. So let's see what other information is given to us. We need a and b and the center in order to make the equation of an ellipse. The length of the minor axis is 10. Great. That means that 10 equals 2b, right? And that b equals 5. And we're going to have to find b squared to use that equation, right? So we know that the equation for this ellipse always follows this format, equal to 1. The major axis is in the vertical, right? So the major axis would be 36, a squared, and that goes attached to y. The center is at -2, 4, so the numerator would be y minus 4 quantity squared. And that the minor axis would be 25. That's attached to the x because, again, that vertical stretch. And that would be x plus 2 quantity squared. And here is the equation of our ellipse, okay? We keep going into that, right? Write the equation of the ellipse with the given conditions. Well, now they have the center. Oh, and we see that the major axis is vertical, and we have a and we have b. This is actually fairly easy, right? You need the center, you need a, you need b in order to build this equation. We know that an ellipse is set equal to 1. The center represents the translation from the origin. We know that x, if it's -3 is our center, then x has shifted 3 units to the left, which is x plus 3 quantity squared. We also know y has shifted up 4 units. So we write that as y minus 4 quantity squared. And since the major axis is vertical, this is like a vertical stretch kind of thing, right? That's where the major axis is located. That the a term, which a squared is what's important, 36. And the b squared term, which is 2. Well, the a squared term, the larger term, is always where the major axis is located. If it's a vertical axis, we would put 36 under the y variable, and we'd keep 2 under the x variable. And that was a quick one, right? We have one more equation, and I'll let you guys end this video. We have the center, we have the length of the major axis, we have the length of the minor axis. Again, you need 3 things in order to make the equation of the ellipse. You need the a squared term, the b squared term, and the center. And it seems like we actually have this almost, as good as we need it, right? We know that the length of the major axis is set equal to the a. If the length is 15, well, that's double a. A is the distance or the length of the semi-major axis. So doubling a would give us 15. That gives us a to be 7.5 and a squared to be 56. 0.25. Well, the length of the minor axis would be set to b, or 2 times b, right? Double b, which gives us b to equal 4, and b squared equals 16. Okay. The center is -7, 5. So where's the major axis? This one's we don't know where the major axis is, right? So this is a weird question. It's not hard, but we have to kind of think of 2 cases because we don't know if we don't have any other information. Is the major axis, horizontal, or is the major axis vertical? We're going to set the equation in both cases. What if the major axis is vertical? And what if the major axis is horizontal, right? How would these equations change? Well, one of the things that would definitely not change is that the equation of ellipse is set equal to 1, and the equation of ellipse is set equal to 1, right? And the other thing that wouldn't change is the translations of the center. They both, in both cases, we know that the center is -7, 5, so we can write the translations as x plus 7 quantity squared. And y minus 5 quantity squared. And this would also be x plus 7 quantity squared, y minus 5 quantity squared. And again, if the major axis is vertical, then it's attached to the larger value, right? We know that a squared and b squared are 56 and 16 respectively. So if the major axis is vertical, we would say 56.25 would go with the y value. And then that would leave 16 for the minor axis. And then obviously if the major axis is horizontal, this would be 56.25. And again, the y value would be 16. So this answer actually is a 2-pronged answer, right? Knowing what they give you. They don't give you enough, so you have to think and assume 2 cases. Hope that was helpful. We're going to practice some of that tomorrow in class. Have a good day, everybody.